right. So you can probably see that there's various tricks that you can play to if you were to start with x squared plus y squared plus z squared equals 1, and we know that this is a sphere, right? And various tricks that you could play to turn the x into that and the y into that, etc. The question is, what do you do? How do you turn 1 into 36? Right? Well, yeah. Now, I'd start by saying you cannot say let's make the substitution 1 equals 36, right? Yeah. But what you can do is just not start with the 1. You can just start with 36. And
also the thing is it's minus 2y plus 2.
I'm sorry. Minus. Okay. Yeah. Okay, my mistake. So this is a hyperboloid, right? In fact, this hyperboloid relates to this hyperboloid. You might remember we just talked about, and I forgot to erase the little the little thing there. So you can see the recording for this other question, but this ends up being a hyperboloid, as I recall seconds ago, was of 1 sheet. Right? Okay, so this is a very similar thing. The only difference is there's a 36 over here on the side. That just means that the hyperbola that you end up with is a little bigger, right? But it's still pretty much the same thing, right? If you prefer, you could look at this one that we're now interested in as coming from the previous by dividing through by 36. Right? And you can see, from this point of view, you can see that this one is just 6 times as big as that one. Yeah. So different way to think about it. Suit yourself. Either way is fine. But so this is just a hyperboloid that's 6 times as big as the previous hyperboloid. Okay. All right. So that's our starting point. Are you happy with that?
Yeah.
Okay. Okay. And let's see. Correction. Let me. I just erased what I wanted to keep. Okay. So I'm going to erase this part, because I just want to call this my starting point. Okay, so then there's this sort of stretching and translating process that follows. And you want to see that, the rest of this?
Sure.
Okay, all right. So again, you have options. When you have something like this, that's going to involve a stretch in the y direction, but it's also clearly going to involve a translation. You can go in various different orders, and there's various different pros and cons. In this case, I want to do the translations sort of all at once, because they're easy to do all at once. And so I'm going to first replace x with x minus 1, y with y plus 2, and z with z plus 1, all at the same time, thus giving me x minus 1 quantity squared minus y plus 2 quantity squared plus z plus 1 quantity squared equals 36. All right? Now, I wrote this as 3 different substitutions, but each one of these corresponds to a translation. So altogether, we're just taking this hyperboloid, and we're translating by way of a vector, the vector being 1, -2, -1. Yeah. Okay, so that turns into that. All right, now all that's left is, well, you can see I'm looking good in the first term here. That is what that's supposed to be. Right? I'm not quite there yet with that. I've got y plus 2. I need 2y plus 2, so no problem. I'm just going to replace y with 2y. That'll fix that. And then similarly, I'm going to have to replace the z with 3z, because the plus 1 is already where it's supposed to be. So, okay, so next step, I'm going to replace y with 2y, so that's a stretch in the y direction by 2. And replace z with 3z. Stretch in the z direction by 3, and we win. So we now have x minus 1 quantity squared minus, okay, well now 2y plus 2 quantity squared, and then plus 3z plus 1 quantity squared equals 36. Okay, so from my original, I say original hyperboloid, this itself is a stretch of the previous hyperboloid, right? But from that hyperboloid, you translate by this vector,
Right.
and then that's right, and then you magnify by 2 in the y direction and 3 in the z direction. Oh, I said, oh gosh, you squish. Oh my gosh, I wasn't thinking backwards. This is a squish by a factor of 2 in the y direction, and this is a squish by a factor of 3 in the z direction.
Right.
Yeah. Okay. Everybody good?
Yeah.
You all know what I meant. Okay.
Yes.
Great. Okay.
The drawing's going to be fun.
The drawing is a challenge. Yeah, that's right. And as long, so let me say a quick word about that. So as long as your drawing is, don't worry so much about whether your final picture of the shape is beautiful, right? But make sure you draw a reasonable representation of what is this translation. So if you draw, you say, well, I'm translating, you could draw like here's the original hyperboloid, draw the other hyperboloid and say translated by this vector, and draw that vector and indicate clearly what that vector is, what the coordinates of that vector are. That's fine, and how good the art is doesn't matter.
Right.
The point is how much does the drawing convey the idea that you're trying to communicate.
Right.
Right. So likewise, if you clearly indicate by a combination of drawing and words that you are squishing by a factor of 2 in the y direction, great. We don't expect the art to be great. Right. And likewise here, just a description is fine.
Okay, cool.
I mean, a description accompanying your attempt at the drawing is fine. Yeah, exactly. We don't expect perfection. Yeah. Okay.
Thank you.